Graph representation. There are kind of main two representation for graph, and they are most common known as adjacent matrix and adjacent list. Let's start by adjacent matrix. Adjacent matrix is a 2D array of size v times v, where v is just the vertex number in a graph. It is used to represent a finite graph with zeros and 1, where zeros means there are no edges between the vertices, and 1s means there is an edge between the vertices. So the size of it is v times v, so it's a square matrix. The element of the matrix indicates whether a pair of vertices are adjacent or not in the graph. That means there is an edge between them or not. So for example, in our graph here, we have 1 and 2, there is an edge there, 1 and 3 has an edge, 1 and 4 has an edge. But 4 and 2 does not have an edge. So that's being represented here. Let's say 1 and 2, we have an edge here, 1 and 3 have also an edge, 1 and 4 we have also an edge. But 1 and 1 in our case doesn't have an edge, and 1 and 5 does not have an edge. So those two are 0, and the others 1, 2, 1, 4, 1, 3, all of them are connected. So this kind of has an edge. For example, 4 and 5 does not have an edge. So let's check 4 and 5. It doesn't really need. That's basically the adjacent matrix. Now, for the other format of representation of the graph is adjacency list. So adjacency list is a representation of graph as an array of linked lists. The index of the array represents a node. So we have a node 1, node 2, node 3, node 4, node 5. Those are the index, and at the same time it is a node. So for example, this node 1 is this node. And each element of the linked list represents a node that is connected to the node by an edge. What does that mean? So we have 1 connected to 2, connected to 3, connected to 4. So we have this node connected to 2, connected to 3, connected to 4. This 2 connected to 1, connected to 3, connected to 5. This 2 connected indeed to 1, 3, and 5. And that's basically the idea behind the adjacency list and adjacency matrix.